Hi there, let's look at section 12.1, tangent lines. And this is, we're starting chapter 12 on all things circles and different lines that you can create on circles and how those relationships, or what relationships get created. In this chapter, or this section, it's just tangents. Tangent lines look like this picture here, where it is a line that just touches the circle at one spot. It doesn't intersect it, it just touches the edge of it. That's called the point of tangency. And there's some relationships that happen with that point of tangency. If you draw a radius to the point of tangency, it will always create a right angle. It'll always be perpendicular to your tangent line. So then, of course, we have things that happen with right angles and right triangles, and so let's use that. One of the other things, if you'll remember that the sum of the angles in a polygon is 180 times n minus 2. So if you have a pentagon, it'd be 180 times 5 minus 2. And that's the sum of the interior angles. Okay, so if we look at this problem right here, what I've done is I've drawn these two tangents. You can see there. And because this is a radius drawn to the point of tangency, that would be perpendicular. They have told me that this angle right here is 117, but I also, because of this relationship, know that that's a 90 and know that that's a 90. So I've got a 90, a 90, and a 117, and they want to know what this one is. Okay, remember what I just said over here. If you look at the picture, the quadrilateral, or I guess the polygon, is a quadrilateral, this shape right here. And I should be able to figure out that the sum of these four interior angles is 180 times 4 minus 2, which is 180 times 2. If all of those angles add up to 360, then I'm going to do 360, subtract my 90s, subtract my 117, and I'm left with an angle of 63 degrees. So angle X would equal 63 degrees. All right, so that's kind of how we use this, like this relationship. It creates right angles, and then we do stuff with it. All right, see if you can figure this one out. We're looking at, for this angle right here, again, so looking for an angle measurement. You can see that this one is a tangent. This is not a tangent because it hits the circle in two places. But we are kind of looking at this triangle here. See if you can solve for X. Okay, so ideally you saw that it was a triangle. The tangent line is perpendicular to the radius, so in this case it actually is a diameter here. And so you have a triangle, the sum of the angles is 180, take 180, subtract your 90, subtract your 38, it leaves you with a 52 for X. Okay, let's work a little bit with side lengths instead of angle measurements. In this example, you can see that I've got the radius and the tangent line creating this right triangle. And I want to know, like the radius, I want to know this short leg. Now, I don't know that this is a special right triangle in any way, but I should be able to do maybe some Pythagorean Theorem on this because it's a right triangle. But it's a little bit tricky. Be careful, because this is one of your legs. It's an X. This is your other leg. It's 12. So I'm going to have x squared plus 12 squared. But this is where it gets tricky. This exterior part is 8, and then this is x. So the entire hypotenuse would be x plus 8. I'd have to add those two together. All right, so let's do our Pythagorean theorem. It's going to be x squared plus 12 squared equals, and the way it looks is it's x plus 8 squared, like that. Now, it is going to be super tempting to just call that x squared plus 64, but that is not the way that works. What we have to do with that is write it twice and then FOIL it, because we get more than an x squared plus 64 out of that. So I'm just going to keep going here. X squared plus, I guess I could change that to a 144, and then do FOIL. First, outer, inner, last. Okay, now I'm going to want to get everything, well, looking at this, I would try to get things on the same side, combine some like terms, but if I subtract x squared on both sides, that x squared goes away entirely, which isn't all bad. Okay, so now I just have x terms and I have constants, so I'm going to get my x's. I guess they're already over here on the right side, this 8x and 8x. I'll combine those, and I'm going to move this 64 over to this side. So let's subtract 64 on both sides. And 144 minus 64 is 80. And that equals 8x plus 8x is 16x. And the 64's went away. Divide by 16, and we have it. X is 5. All right, so be careful on those ones. They like to do this kind of business to us where we have to write something squared, but you got to FOIL that. All right, see if you can do this one. Very, very similar problem. You try this one on your own. Go ahead and take a minute and pause the video and come back when you're done. All right, here's what I got. Hopefully you got the same thing. As an exact answer, 16/3. If you round it off, it's 5.3. Let's keep going. Right, here's a new property that we have, that if you have a tangent from some point out here, we'll call this point B, and you draw a tangent to the top of the circle, but then you also draw it down to the bottom of the circle. Now there's only one tangent line, only one place you could really draw that would actually hit that at one spot. But if you do the tangent on the top and the bottom, these two tangent segments are going to be congruent to one another. Now we can kind of fancy that up a little bit, and it looks like here we have this triangle around, well, really it's the circle is inscribed in the triangle. And what you have to kind of look at it is, don't just look at it as a triangle, but look at it as this is a tangent segment and this is a tangent segment. And ignore all of this stuff over here. If this tangent segment is 15, then how long is this tangent segment? Also 15. Okay, and then we would do that in all around the circle, or all around the triangle. This little tangent segment is 8 centimeters, so this little tangent segment is 8 centimeters. And then let's do it up here by A as well. This tangent segment is 10 centimeters, so this tangent segment is 10 centimeters. And the question is asking what's the perimeter of our triangle. So then I can add up all the sides, and ultimately probably what I would do is in my calculator I would do, well, I don't know, I could do some of this in my head. I'm going to have a 10 and another 10, so there's 20, plus a 15 and another 15, so I'm going to add 30, plus an 8 and another 8, plus 16, and I'm left at 66 centimeters for the perimeter. All right, see if you can work your way around this next triangle, and they're not asking you for the perimeter, they're actually telling you that the perimeter is 88. So could you figure out the length of QY? All right, go ahead and pause the video and work through that problem. Come back when you're done. Okay, I got it to equal 12 units. The way that I set that up is I took the 15 and 15 to get 30, the 17 and 17 to get 34, plus, and I just labeled this, I called it A. I just labeled it as an A and another A, so that's plus 2A, and all together that should get me a perimeter of 88. And then I just did some algebra, combined like terms, moved it over, solved for A. I got A to be 12, which is ultimately the QY measurement that they want. All right, hopefully you got that too. All right, that's all we got in 12.1. Good luck.